Building your dream kitchen is the goal of many woodworkers, but the overall scope of the project can be a little intimidating. After all, we're looking at a whole room full of woodworking. We have upper cabinets, base cabinets, doors, drawers, face frames, finish panels. Okay, it can be a lot intimidating. But the truth is, building your own kitchen cabinets isn't all that difficult. We essentially have a big box filled with more boxes, our drawers, and covered with portions of boxes, our doors and finish panels. So it's all just boxes. And building boxes isn't rocket science. We'll build base units and upper cabinets in both traditional face frame and European styles. We'll outfit these with a couple different kinds of drawers and pullouts. Plus, we'll craft beautiful yet simple doors and finish panels to dress up our cabinets. So let's go make some cabinets. Before we build anything, there's a few standard sizes you want to keep in mind when making kitchen cabinets. All of these dimensions are based on ergonomics, or the way our lives and bodies interact with the cabinets we're about to build. Base cabinets are generally 36 inches tall, including countertops. This height off the ground puts things in front of us on the countertop at a comfortable level for easy working. A little lower and we'd have to bend slightly when chopping vegetables or preparing food at the workspace, so you'd end up hunched over and feeling some back pain at the end of the day. Any taller than that, and we'd be on our tiptoes trying to reach what's in our upper cabinets. So 36 inches tall is the key height, and it's no coincidence that appliance manufacturers use 36 inches tall as their standard as well. So dishwashers and ovens and cabinets all sit at the same height in a kitchen for a seamless, expansive countertop. The depth of base cabinets is generally around 24 inches. This really has more to do with materials than anything else. When you rip a 4-foot wide sheet of plywood in half, you end up with two 24-inch slabs that can be cut into cabinet sides and bottoms. Base cabinets sit on top of supports or toe kicks that are generally 4 inches tall and set in 3 inches from the front of the cabinet. This provides enough room to stand at the cabinet without stubbing your toes. Upper cabinets are generally around 12 inches deep, allowing us to get 4 slabs from a sheet of plywood. This is a good size to store most of the items we use around the kitchen, and provides a good setback so the uppers won't interfere or get in our way when we're working at a base cabinet. Upper cabinets are usually installed 18 inches above the countertop surface. This leaves plenty of room on the counter to work and to put small appliances like coffee makers and mixers. Plus, 18 inches is an easy reach when storing dishes and goods in the uppers. There's really no standard height for upper cabinets, but 30 inches tall is pretty common. That's about as tall as most people would be able to reach without grabbing something to stand on. There's two basic types of cabinets out there, European and traditional. Traditional cabinetry is often called face frame cabinetry because the boxes are dressed up with a face frame that's applied to the front of the carcass. The face frame adds a distinctive border and style to the cabinet. European cabinetry, which I'll refer to as Eurocabs or frameless cabs, don't share that face frame assembly and can often provide a sleeker, more contemporary look. European cabs do have a slight advantage when it comes to spatial efficiency. Since there's no face frame to get in the way of anything and take up any more room, we're left with a little more storage in each cabinet. And saving a few extra cubic inches per cabinet can yield as much storage space as a whole extra refrigerator in your kitchen. So which is stronger or better? Well, the truth is, once they're both attached to your kitchen walls and all locked together, neither are going anywhere, and both will provide decades of service. If you choose to go with traditional cabinets over Eurocabs, build your face frames first. Face frames are what you see, and they dictate the width of the box behind them. It doesn't take a factory full of equipment in order to build kitchen cabinets. If you've got a saw, a drill, a hammer, screwdriver, you've got the basics and you can get the job done. If your workshop and tool collection has a little more, let's say a router, pocket jig, a stapler, it'll make things even easier and you'll be able to tackle more options. Kitchen cabinets are made from sheet goods, and by that I mean plywoods and melamine. When buying plywood, look for straight and consistent layers in a quality cabinet grade plywood, preferably obtained from a plywood supplier. Avoid plywood with a wavy substrate. It could warp. Melamine is just particle board with a thin plastic coating applied to the outside edges. It comes oversized by an inch, so a 4x8 sheet is actually 49 inches by 97 inches. It's less expensive than cabinet grade plywood, and the slick white surface is easy to clean and reflects a lot of light in an enclosed box. We don't use solid wood for our cabinet boxes. Kitchen cabinets are screwed to the walls of our homes, and solid wood expands and contracts, and our houses really don't. So it's best that we save the solid wood for our doors and our frames. Of course, we'll also need fasteners like nails and screws, as well as special cabinet hardware such as hinges and drawer slides or runners at the end of the process. One last thing I want to mention along with cabinet materials are countertops. There are a lot of different types of countertops out there. Laminates, solid surface, stone, and even concrete. They vary tremendously in weight, but the cabinets we're going to build here will be able to support whichever countertop you decide to have installed. Cabinets take up a lot of room in the shop. On a large job, I may pre-cut and stack all of my parts, holding off on assembly until just prior to installation. This gives me a lot more room to work in the shop and makes assembly and finishing a lot easier. But there is a trade-off. You end up with a lot of parts floating around. So you need to stay organized by labeling all the components and keeping the parts for each cabinet stacked together in an area where they won't be in the way or need to be moved. I prefer, whenever possible, to build and stack all the boxes until installation. It's nice to have the completed cabinets on hand so that we can measure for doors and drawers and just to keep a visual reminder of what still needs to be done to wrap up the job. Whether building wall cabinets or base cabinets, you always start with the basic box. I start by rough cutting full sheets of plywood or melamine into manageable sizes. The easiest way to do this is with a circular saw. I cross-cut sheets once at 32 inches. I found this is a great length because it leaves me with a portion of a sheet that it can be used for cabinet sides or bottoms. The resulting pieces are light enough to maneuver safely and easily on the table saw. Now switching over to the table saw, let's cut the sheets into their final sizes. It's important to think about our cutting sequence. We want to ensure that all of our pieces are consistent sizes. In order to accomplish this, I cut all of my sides to height at the same time. Now, adjust the fence for the depth of the box and cut the bottom and sides to depth. The next step is to size the bottom and the nailers and stretchers to length. Then, cut all of the nailers and stretchers to width. By following this sequence, we're guaranteed that all of the components will be the exact same length for any given access. The last part is to size the back. Cut the 1/4 inch thick back panel 1/2 inch wider than the bottom and 1 inch shorter than the sides. This will ensure that the back sits properly in the grooves that we're about to cut. The last step at the saw is to cut a few grooves to hold the back panel. I've installed a 1/4 inch dado blade and raised its height to just a hair over a 1/4 inch. I don't measure to adjust my fence here. Instead, I grab one of the nailers and place it in between the fence and the blade. That's the distance I'm looking for to properly position the back in the cabinet. We need to cut grooves in one of the stretchers, in both sides, and the bottom. Don't have a dado blade? No worries. You can do the same thing with a standard blade just by adjusting the fence and making a few extra passes. Tear out's one of the biggest things that you may have a problem with when cutting plywood. If you notice that you're having problems with tear out, there's a few things that you can do to reduce or eliminate the problem. Be sure to use a sharp blade and one that's made for plywood or melamine. These blades have more teeth with a less aggressive hook on the blade. Another way is to use a zero clearance insert in your table saw. They help support the wood fibers while you're cutting. You can buy one or make your own. Finally, a piece of painter's tape on the back side of the cut will help keep the fibers together. Just remove it after the cut. Before we assemble our cabinet, we'll need to do something to cover the exposed edges of the plywood. We won't want to see these in the finished cabinet, and it's much easier to cover them before assembly. I cover any edges that will be left exposed in the finished cabinet. We'll apply a pre-glued edge banding tape to the bottom, sides, and one of the nailers. You can get in a bunch of colors and a variety of wood grains. Start with a standard household iron set to medium heat. For most irons, this will be the polyester setting. While the iron heats up, just measure off a piece of edge banding tape a couple inches longer than the component you're going to band. This tape is pre-glued with a heat-activated adhesive applied to the back. I center the tape on the component and work the iron along the edge. My first pass holds the tape in place. Then I work my way back, really letting the glue melt and adhere. Next, to ensure a good bond, I burnish the tape with a block of wood, pressing down in the center, then applying pressure to the edges. Use a razor blade to trim the tape to length, scoring it from underneath and snapping it off from above. Then I use a trimmer to flush the edges. The trimmer leaves edges a little sharp, so to wrap up the whole process, I use some 150 grit sandpaper to ease the edges. With all of our parts cut to size and edge banded, we're ready to start assembling our cabinet. But before I drive any fasteners at all, I like to draw a few lines on the parts, 3/8 of an inch from an edge. This will help to center our fasteners and aid in assembly. And I use this simple shop-made gauge to make the task even faster. Now that all of our parts are marked, we can put it all together. All of the joinery in the cabinet are simple butt joints reinforced with screws. I tack the parts together with 1 1/4 inch long staples. This isn't structural, it just keeps the parts from moving around as I assemble. Start with the side and the bottom. Here the back of the parts are against the bench. I'm lining up the front edge of the cabinet and I just tack them together. Then tackle the other side. I'm using a bench dog to keep the cabinet from sliding around. It gives me something to press the cabinet up against while I make any minor adjustments to alignment. A block of wood clamped to the bench top would accomplish the same thing. Now, roll the cabinet onto its top and place the front stretcher in position. And a few staples hold it in place. Now, set the cabinet on its bottom and slide the back into the grooves. Fit the rear stretcher into position and align it with the top and back. A couple more staples secure it. Roll the cabinet forward onto its face. And install the 2 nailer strips. Press them against the back for a good fit. And secure them in place with a few staples. The staples do a good job of holding everything together. They act just like little clamps. But if you don't have a stapler, you don't need to run out and buy one. A brad nailer or a finish nailer will work just as good. Or you can always just use clamps to hold everything together while you drive the screws in. I lay the cabinet on the floor and complete one side at a time. Drill and countersink a series of holes, and then drive in 1 5/8 inch screws. I put 2 screws in at each stretcher or nailer, and on the bottoms, I'll put 5 screws in for a base cabinet and 3 screws in for a wall cabinet. Stay a good inch from the edge in order to avoid splitting the material. And don't forget about the groove along the back edge. Flip the cabinet over and repeat the process. And that's how to build a basic box. We mentioned earlier that base cabinets have an overall height of 36 inches. That includes a 1.5 inch thick countertop surface and a 4 inch tall toe kick. That leaves us with a box that's 30.5 inches tall. The depth of a base cabinet is 24 inches. That's no problem if you're using oversized melamine, but you'll never rip 2 24-inch pieces from a 4-foot wide piece of plywood. The saw kerf wastes about 1/8 of an inch of material per cut. The simple solution is just make your cabinets 23 3/4 inches deep if you're working with plywood. And overall cabinet width will be determined by your needs. Now, if you're planning on combining a drawer with doors in your base cabinet, you'll need to cut an additional stretcher. We'll use this to separate the drawer from the doors and to give the doors something to close against. Following our basic box strategy, cut the parts to size. The nailers, stretchers, and bottom are sized 1.5 inches less than the cabinet's overall width. With all of the parts cut out, apply edge banding to any exposed edges. During assembly, use a couple of scrap wood spacers to position the drawer separator and ensure it's parallel to the top and bottom. The actual height of placement will be determined by the size of the drawer you plan to use. I prefer applied toe kicks rather than ones that are integral with the cabinet sides. It makes box building a little easier, and it helps me maximize a sheet of plywood. Generally, I'm making the toe kicks from remnants from the cabinet construction. Rip plywood to the height of the toe kick, 4 inches tall. Then cross-cut to width. You'll need 2 pieces that are the overall width of the cabinet and 2 pieces that are 19.5 inches long. This will provide the proper setback for the toe kick. Drill for pocket screws along one edge of each piece. Staple and screw the kick together. Then secure the toe kick to the base of the cabinet with the pocket screws. Here's a tip. If your cabinets will be resting on concrete, use pressure-treated plywood to make your toe kicks. They resist the moisture issues associated with concrete slabs a lot better than standard plywood. That was fast and simple. Now let's take a look at wall cabinets. Wall, or upper cabinets, are built in the same way as our base cabinets, except using a solid top rather than a couple of stretchers. Wall cabinets measure out about 12 inches deep. And while there's no standard height, 30 inches is pretty common. Also, I generally like to keep wall cabinets less than 3 feet wide because of deflection. The bottom of the wall cab acts as a shelf, and longer shelves will deflect, sometimes noticeably under loads and span. Cut all of the components out following our basic cutting strategy. When using plywood, I adjust my cabinet depth to 11 3/4 inches. Skip cutting the stretchers. We don't want to stare up at a big hole left in the top of our wall cabinets every time we open them, so cut an extra bottom, which will be used as the top. With all of the components cut out, apply banding to any edges that will be visible once assembled and installed. Before assembling the cabinet, we'll need to make provisions to support the shelving inside of it. My method of choice is adjustable shelf pins. With a 1/4 inch spiral bit chucked in my router, I plunge an array of holes along the sides using a template. It's important to note the top of the side and always reference the jig to the top so our hole orientation will be consistent and the shelves will sit level. Mine's aluminum, but you can make a simple template like this from 1/2 inch plywood. Shelf pins can be employed in your base cabinet as well. The choice is up to you. Assembly is the same as our basic box, except I use 3 screws along the top and the bottom to reinforce the joints. Our wall cabinets still need some shelves, and there's a couple of different ways to make them depending on the load and the span that they'll be subjected to. A simple shelf can be fashioned just by banding a slab of plywood. Cut the slab an 1/8 inch less than the interior width of the cabinet, and about a 1/4 inch less than the depth. If you anticipate a heavy load, like lots of dishes or canned goods, there are ways to make more resilient shelves. The method I turn to most often is to apply a solid wood lip banding to the front edge. Rip a piece of 3/4 inch hardwood stock 1½ inches wide and cut it to the same length as the shelf. Then raise the blade to the same height as the shelf thickness and adjust the fence to about 11/16 of an inch. Run the hardwood stock through the saw to create a shallow rabbet. Now, glue and clamp the hardwood strip to the front of the shelf and allow it to cure overnight. Once dry, plane or sand the lip banding flush to the shelf. It may not seem like much, but the lipped banding acts like a little I-beam and will help the shelf support a lot more weight before deflecting. Face frames add rigidity to the box, but more importantly, they impart a traditional furniture look to the cabinet, which many people prefer. To build a face frame, I began with 3/4 inch thick stock ripped into 2 inch wide pieces. Cut 2 sections 3/4 inch longer than the height of the cabinet you plan to use. This will provide a nice reveal and detail. Then cut at least 2 rails or horizontal members 4 inches shorter than the desired width of the face frame. You'll need 1 each for the top and bottom of the cabinet, plus 1 for each drawer as well. For joinery, we'll turn to pocket screws. They're a fast and easy way to make a strong joint in a face frame application. There are a bunch of jigs out there to cut pocket holes, but they all work on the same principle of drilling a hole at a steep angle to guide a screw and connect 2 parts. I drill pocket holes in the rails, or horizontal members of the frame, in line with that piece's grain. It's important to remember this because pocket holes placed across a stile create a weak point in the stile and also cause the screw to grab in the end grain of the rail. End grain doesn't have nearly the holding power of long grain. When assembling the joint, it's important to use the proper length fastener for the application and to keep the faces of the frame in the same plane. These quick adjusting clamps work great for that. To add the drawer separator, rather than measure, which could be a hair off from side to side, I use a spacer block to ensure consistent location of the rails. Align the completed frame with the top edge of the cabinet and center it along the width. You should have a 1/4 inch reveal on the insides of the cabinet and 1 inch on the outsides. We'll attach the frame to the cabinet, turning again to pocket screws. I've drilled a series of holes along the face of this cabinet prior to assembly, spaced about every 6 to 8 inches on center. I use these proprietary clamps to hold the face frame to the cabinet while I attach it, but any long clamp will work too. Start securing the frame to the cabinet and work your way down to the bottom of the case. You can check your reveals as you go, making sure they're even. That in turn will ensure your cabinet is square to the frame. If you're not into pocket joinery, you can build your face frames using lap joints or mortise and tenons. And you can always attach the face frame to the cabinet using biscuits or nails. A real high-end decorative touch can be added to your cabinets by applying a bead detail to the openings. I've made some simple 1/4 inch beading using the router table, and I've mitered the ends to fit. And now I'm just pinning it in place while the glue sets up. Here are a few tips I'd like to pass along about integrating face frames into your cabinetry. First, keep in mind you won't need to apply any banding to the front edge of your cabinets. The face frame covers the exposed edges. You won't need an extra stretcher for each drawer either. Our face frame takes care of that separation. Second, remember to reduce the depth of your plywood panels by 3/4 of an inch to make up for the face frame's thickness. And be sure to drill for your pocket screws before assembling your cabinets. It just makes things easier. Finally, but most importantly, build your face frames before building your cabinets. The layout of your kitchen will dictate the overall width of the face frames. The cabinets behind them will be 2 inches narrower than the face frames. One of the best ways to increase the efficiency of your kitchen cabinet project is by the addition of drawers and pullouts. Nobody likes to bend over and reach into the back of a cabinet in the middle of cooking dinner, so drawers and pullouts just make life easier. The difference between a drawer and a pullout is just semantics. They're both just boxes with a mechanism that allows them to open and close easily. Before you build any drawer, you've got to consider your hardware first. Commercial drawer slides have certain clearances which must be incorporated into the drawer design. For example, an undermount slide requires different clearances than a side mount slide. There are countless joinery options available for crafting drawers. We'll focus on two of them, a quick and strong drawer made with pocket screws and a classic dovetailed drawer. On the pocket screw drawer, the screws pass through the front of the drawer and into the sides, acting like little tenons that keep the drawer together and transfer the opening and closing stress from the drawer front to the sides. I'm using 1/2-inch plywood for this drawer. Rip a series of drawer blanks to height. Now cross-cut 2 sections to the desired length. In the case of a base cabinet, it's 22 inches. Next, cross-cut the front and back of the drawer to the desired width, minus 2 times the drawer thickness. We'll use 1/4-inch plywood for the drawer bottom. Size the bottom a 1/2 inch wider than your drawer front and a 1/2 inch less than your drawer sides. If you're planning to keep real heavy items in this drawer, you can always make the bottom out of 1/2-inch plywood. With a 1/4-inch dado blade in the table saw, cut 1/4-inch deep grooves along the edge of each piece to hold the drawer bottom. I'm locating this groove about 1/2 inch from the edge. Then, to make the drawer a little more friendly to the touch, I ease the top edges of it with a bullnose bit in the router table. You can do the same thing with a roundover bit, or even by sanding the edges smooth. I had to change my drill depth and my pocket hole jig setup to accommodate the 1/2-inch material. And now I'm just drilling a few pocket holes in the outside faces of the drawer front and back, being mindful of the groove for the drawer bottom. Assembly is simple. I do a quick dry fit. And now I'm holding things together with these corner clamps. But a standard clamp placed across the drawer will do the same thing. Just be sure to use the correct length screw for this application so you don't blow out through the side. A quick check for square, and the drawer is done. Our pocket screw drawer is complete. Later, we'll apply a false front, which will cover our pocket screw holes. If we were using this as a pull-out, we could plug those holes just as easily. Dovetail joints are very strong, offering a lot of glue surface and a mechanically locking joint. Plus, they're one of the hallmarks of fine craftsmanship. When I have a bunch of dovetail drawers to make for a kitchen project, I turn to a common half-blind dovetail jig. Most every woodworking store or catalog sells a version of this jig, and the one you get may be a bit different, but the theory behind them is all the same, and so are the tips and tricks I've learned to use them with ease. There's no shortcutting the setup on these jigs. Expect to spend some time getting it just right. And keep in mind that any change to your router bit height or your stock thickness will change the quality of the joint you cut with one of these jigs. But once it's dialed in, you can really crank out some drawers. Cut your drawer components by ripping a few blanks of plywood. Then cross-cut the front and backs to the desired width of the drawer. Cross-cut the sides about a 1/2 inch shorter than the desired length of the drawer. This measurement will vary a bit depending on the setup of your dovetail jig. Next, I stage all the parts on the bench and mark the inside of the drawer and whether it's a side or a front or back. I also mark the little reference number on the top edges of the drawer. At the dovetail jig, install a side in the vertical portion of the jig. This will be our tailboard. And to benefit from the mechanical locking advantage of the dovetail joint, tails must always be on the sides. The pin board is a front or back, and we'll place that in the horizontal portion of the jig. Note that I have the insides of the drawers facing up and out, and I also have the reference numbers facing towards the outside of the jig. I make sure that the drawer parts are positioned against the locating stops, and begin routing by making a scoring cut across the side. This will help reduce any tear out that may occur. Then I just route along the template, being sure never to lift the router, which would ruin the joint. Some compressed air gets rid of all of the dust. And then I rotate the pieces around over to the other side of the jig. Again, I make sure the reference numbers are facing outwards. With everything clamped down, route the other end of the pieces. Then just repeat with the two remaining components. Here's the reason those reference numbers were important. If we assemble the joint backwards, we end up with a joint that's off-center and just doesn't look good. So I've got all the reference numbers oriented the same direction, and now I'm just going to test the drawer joinery. Now I'll take a quick measurement for the drawer bottom. It's going to be 1/2 inch wider and 1/2 inch longer than the interior of the drawer. And that will just be cut from a piece of 1/4 inch ply. We need to cut the groove for the bottom. And again, I turn to the 1/4 inch wide dado, set a hair higher than 1/4 inch. But now fence adjustment will be dictated by our joinery. Grab one of the drawer fronts and line up a socket with the dado blade. Be sure the numbers are facing away from the fence. Placing the groove here will hide it from view when we open the drawer. I finish up machining the drawer by easing the top edges. For assembly, just a little dab of glue in each socket does the trick. No need to overdo it. Too much glue just means dealing with squeeze out later. I set the front and the back onto one of the sides, and I slip the bottom into place. Now I seat the tails and check for square. Everything looks good, so I just set the drawer aside to dry. No clamps are needed, as a well-cut dovetail has plenty of mechanical strength to hold things together while the drawer cures. It's time to dress up our boxes by adding doors, finish panels, and drawer fronts. There's a ton of styles out there, and the skill required to build them is just as varied. For these, I'm going to show you how to make an easy stub tenon application with shaker styling. Doors, finish panels, and drawer fronts can all be built using frame and panel construction, and they're all made the same way. Frame and panel assemblies are composed of three components: the panel, and then the frame, made up of vertical members called stiles, and horizontal parts called rails. I remember which is which by thinking of a basic railing on a porch or a set of stairs. The part I put my hand on is the railing, or rail, and always runs horizontally. To build a stub tenon frame and panel, start by ripping frame components to 2.5 inches wide. Then cross-cut 2 stiles that are the desired height of the assembly and 2 rails that are 4 inches shorter than the desired width. Set the saw fence to 1/2 inch from the outside of the blade and raise the standard blade to a hair more than 1/4 inch. Grab the rails and with a miter gauge, cut the shoulders which define our stub tenons. With a 1/4 inch dado blade in the table saw, I cut a 1/2 inch deep groove down the length of each component. Flip each piece around and repeat the cut to ensure each groove is perfectly centered. A dado blade makes quick work of removing the remaining material from the tenon cheeks. Here's a tip: sneak up on the fit. Adjust the blade height slowly, cutting only at the end of the tenon first until it slips into the groove. Dry fit the frame assembly and measure the opening to size the panel. Add 1 inch to the height and width of the measurement to accommodate the groove. Then cut a piece of 1/4 inch plywood to this size to make the panel. I do one last dry fit, just in case there's any adjustments that need to be made. Everything fits good, so let's do our glue up. A little goes a long way when it comes to glue. Don't apply so much that you're battling with a ton of squeeze out. I apply glue to the tenons and along the bottom of the groove. Then a couple of clamps hold things together until it cures. For a little extra insurance, you can always pin the back of the joints with a few brads. The strength of the stub tenon frame and panel relies partly on the glued-in plywood panel, which is dimensionally stable. Don't try this with a solid wood panel, which will expand and contract throughout the seasons. That wood movement will literally tear your door apart. There's 2 more items I need to mention before moving on. The first is, when do we start to think about 2 doors on a cabinet? Well, I usually start thinking about making 2 doors when my door widths approach 18 to 24 inches. I avoid making single doors that are 24 inches wide or more. The second item is drawer fronts. When they get shorter than about 6.5 to 7 inches, you may want to avoid the whole frame and panel assembly and just go right to a slab front. Otherwise, you end up with a whole lot of frame and no panel at all. As a matter of fact, you can use slabs to outfit your entire cabinet if you want to. Now that all the components are built, it's time to integrate the hardware to make our doors and drawers functional. There are a lot of choices for hinges and drawer runners. I usually reach for European hinges and full extension drawer slides. They're extremely durable, easy to install, and offer a lot of adjustment for the perfect fit. Euro hinges come in a lot of varieties, and you get to choose how far the door opens and the overlay or inset of the door. Regardless of choices, they all get put in the same way. The installation of European or cup hinges starts at the drill press with a 35mm Forstner bit. I've laid out my hinge cup location on the door with a center line 7/8 of an inch from the edge and about 3 inches from the top and bottom. Set the press to a slow speed and bore about a 1/2 inch deep. Mounting a fence to the drill press table will help ensure consistent results. If you don't have a drill press, there are some readily available jigs out there to complete this step with a hand drill. Next, use a square to align the hinge on the door and drill a couple pilot holes with a self-centering bit. Secure the hinge with a couple of screws. For the case side of hinge installation, I locate a center line a given distance from the front edge of the cabinet. This distance may vary depending on your hinge make and application, but it should be supplied by the manufacturer. Line up the door, open the hinge arms, and place center marks on the cabinet. Next, grab the mounting plate, line it up with the marks, and drill a couple pilot holes with a self-centering bit. The base plate is then secured with a couple of screws. Then the hinge arm just clips to the mounting plate. Presto, a working door. And a couple little rubber bumpers help to keep things quiet. For traditional style cabinets, the process is the same. Just add a spacer block to the inside of the cabinet to fill the gap created by the face frame. Plus, for inset doors, you'll also need to add a small stop block so the door has something to close against. And keep in mind, if you plan to use pullouts, you'll need a hinge that opens at least 165 degrees so that the door does not interfere with the pullout hardware. Installing the drawer slides begins by separating them into two parts. The smaller part of the slide attaches to the drawer box. I position the height by using a simple shop-made locating jig. Line the tab up with the front of the box and drill a few pilot holes. Secure the runner with 3 or 4 screws along its length. Then repeat the process on the other side of the drawer. These small screws can strip easily, so I use a hand driver rather than a power drill. The larger portion of the slide attaches to the cabinet side. I use a scrap of wood ripped to a specific width as a locating jig. Then just lay the slide in place. Drill a few pilot holes and secure with a few screws. Now check how you made out. The drawer runners should fit into one another and slide in and out of the cabinet effortlessly. To mount drawer slides in a face frame application, install a 1/4-inch thick shim to eliminate the reveal behind the frame, and position the front of the slide assembly at the back edge of the face frame. Then just pre-drill and secure with a few screws. That's it. Our doors and drawers are installed. And remember, you'll need to add a spacer to fill the gap in the cabinet in face frame applications. We're in the home stretch. Now we'll apply a durable finish, install any remaining panels, and install our knobs and pulls. When finishing kitchen cabinets, I look for something that's easy to apply in a home shop. It needs to enhance the beauty of the woods and our craftsmanship. And most importantly, it has to protect our cabinets in what's actually a very harsh environment. Our finish must be able to resist water, grease, alcohol, and some really aggressive cleaners. Luckily, common oil-based polyurethane can accomplish all of that. Begin by wiping down all of the surfaces with alcohol. This will help remove any of the errant grease and waxes left from transport or manufacturing, which could interfere with our finish. Next, sand thoroughly. I start sanding bare wood at 100 grit and work my way up to 180 grit. On plywoods with their thin veneer faces, I generally start my sanding at 150 grit. A shot of compressed air removes the bulk of the sanding dust. You can vacuum it off as well. Oil-based poly straight from the can is kind of a pain to work with, so I like to doctor it up a little bit. I make a simple wipe-on poly that a lot of woodworkers refer to as 3-2-1. "3-2-1 gets its name from the ratio we mix the components in. Take 3 parts paint thinner, or mineral spirits, 2 parts polyurethane, and 1 part boiled linseed oil, and mix well. To apply 3-2-1, you can just flood it on with a foam brush, and I rub it in with an abrasive pad. This creates a little bit of a sanding slurry which fills in the grain as well. After it's had a chance to soak into the wood, wipe the remainder off with a rag. Now the first coat will take a good day or so to dry, but once it has, go ahead and apply a second coat just like the first. Subsequent coats can take as little as 3 or 4 hours to dry, depending on the weather. I apply a minimum of 4 coats. It's a thin finish, so you have to build it up. But once you do, you'll be left with a silky smooth finish which will withstand virtually all kitchen hazards. Keep in mind, 3-2-1 is an oil-based finish, and your wet rags can pose a fire hazard. Spread them out and allow them to dry thoroughly. Applying our finished panels and drawer fronts is a simple process. We just add spacers as necessary and fasten with the screws from the inside of the cabinet. Mounting a drawer front in a face frame cabinet means positioning it just right to get a nice even gap around the perimeter. Using a few shims the same thickness as the desired gap makes the job a lot easier. Once positioned, I drive a couple brads through the drawer bottom to hold things in place. Then I'll secure it permanently with a few screws from behind. The only thing left to do to complete our cabinets is to install any knobs or pulls for our doors and drawers. The choices and selection out there are endless, and prices have no limits either. The biggest hurdle to overcome with installing the knobs and pulls is to remain consistent and uniform in their location. To accomplish this, I use a simple jig for laying them out. You can buy jigs for this at most home centers, or you can make your own. They're really simple. With the centers marked, drill holes for the fasteners, and attach the knobs. And that's it. Building kitchen cabinets really is that simple. We started by making our basic boxes, using accepted and time-tested construction methods. We chose to either use face frames or go with the European look. Then we made some shelves and drawers to store stuff. We learned a simple method to make stylish doors and finish panels, and we applied a foolproof finish to protect our work. All that's left is to enjoy your dream kitchen.